Hello everyone, today I am going to work on this helicopter driving system. So we can start the engine, and once it reach the necessary required RPM we can take off. And so if I stop release the takeoff button or lifting button, I can stay idle in the air, and you can see the chopper has some random movement just like a real chopper. And also if I can move to left or to right or forward or back. So, and you can see the helicopter body rotates accordingly to the movement direction, and also we can turn in place like this as well. Okay, so let me land the helicopter over here. Okay, so this is the system we are going to work on today. Later on we will work on like enabling attacking with the helicopter, but for now let's work on these basic movements. Okay, so this is the usual third person template, and here I have imported this helicopter model. This is the one I'm going to use. This one also have this animation as well. Alright, so let's see how to implement this helicopter driving system today. First, I already have this helicopter folder, and here I have the helicopter mesh. So first, let me play the game. This is what you get. Okay, and here let's create a new blueprint using the type of bone. I'll call it PP helicopter. Right, and here first I'll add a skeletal mesh. Oh, I can just drag and drop, can I? Yeah, I'll call it mesh. And I won't make this the default scene route. No, I think I have to make this the route, otherwise it wouldn't work properly with the floating pawn moment. Right, now I'll add a floating pawn moment component as well, because we can use this to move the helicopter. Right, now let me place this in here. Well, that's too large. I think scale is okay. Let me quickly get some space. Well, we don't need these borders. right? And when I play the game, I am here. I don't need to possess this character, so I'll disable auto possess player for this one and enable auto possess for the helicopter, right? Okay, and the direction this helicopter facing is also wrong. The forward should be in the red arrow direction. So let me set this import rotation to -90 and re-import, because I still have the external mesh that I have imported. So now the direction should be fixed, right? Okay, now the direction is correct, but still I am inside the shop, so this is not the way it should be. So let's add the camera. First I'll add a spring arm component. Where should we attach it? Right in the middle, it should be fine. And let's make it 900 at offset of 300. Not enough. Let's say 1500. Still not enough. 1900. Right, that should be fine. Is it offset? Let's say 500. Okay, and let's set the camera. Let's attach a camera here. Alright, now if I play the game, okay, this is the view I get. And it's fine. First let's add rotation to the camera. So to do that, let me quickly open the third person character, and here we have all the mouse inputs. These two. Let me copy that and paste here. And also here, use pawn control rotation. I have to enable that too for this spring arm. Let's rename this one also. Instead of spring arm, camera bow. I think you guys are also familiar with that name. Right, now if I play the game, I should be able to look around. Yeah, like this. Okay, the next part is moving the helicopter. Well, actually before that, I should first start rotating the blades of the helicopter before starting to move. That means we have to set up an animation blueprint. Also, I feel like this look around speed is too fast for the helicopter, so let me add a multiplier here. Because when I can look around so too fast, it kind of gives away the weight of the object. Right, now it's better. Okay, so alright, now let's look into the animation part. Okay, so first I need to create an animation blueprint. Right click on this skeletal mesh, anim blueprint. Let's call it BPA. BPA stands for blueprint animation helicopter. Right, and here I'll use this animation. Right, so let me drag and drop it here. Oh, but here we can't actually set a speed. We can't, can we? No, this play rate or anything is not exposed, so let me delete that. Right, so here in this skeletal mesh, let's create a blend space, 1D blend space. I'll call it BSP helicopter. Right, and horizontal axis, I'll name this one as RPM. Minimum axis value 0, maximum 100. So this animation I'll add it at the end, and here we need to have something that doesn't have any movement. So let me duplicate this helicopter. Stop. Let's call it stopped. And here let me remove all these frames. 1 2 1 1, so nothing is here basically, and save, and let's use it inside the animation blend space BSP helicopter, and I'll add it here. Oh, that's bad. I don't think that approach will work, but we can do something like this. If we have multiple divisions more than 4, let's say instead of 4 let's add 16, 0 to 5. Okay, here I'll add the idle animation again, and I'll set the rate scale to 0.5. So only this area now this area looks fine, we don't get any issues. So I should start from when I implement this, I should start from RPM 5, and if the RPM is lower than 5, it should instantly become 0. Oh wait, that also could be a problem, because no matter what we do, the blades has to stop at this point. So instead of doing this way using a blend space, I think it would be better if we drive the blades through the animation blueprint itself, through the code. So to do that, okay, let's go back to the animation blueprint, and yeah, this is something that didn't work as expected, but still I'm not gonna cut this part from the video because you have to know that too. So yeah, let me check the skeleton, and here wing base. Right, this is what we need to rotate, right? Yeah, that's the part we need to rotate, wing base. And for this part, rear wing base, this is the part we need to rotate. Okay, so no animations are required. Let me close this blend space. Here let's get mesh space ref pose and add a transform modify bone As the bone, I'll set wing base. Connect. So here no components to modify. I'm gonna modify the rotation, and what I'm gonna do is add to existing. Right now, if I make this 5, this is what happens. Okay, if I make it 10, it's gonna rotate like this. So let me split this and promote yaw to a variable. I'll call it wing rotation. No, wing yaw. By default it should be 0. Okay, now in the event graph I'll add another variable, a float variable. I'll name it RPM. Okay, and then I'll set the wing yaw like this. Get the wing yaw, get the current value, and then get the RPM. Actually, this may not directly represent the actual RPM. This could be some value that represent the rotation speed. Add this together and save. So by default, I'll set RPM to 10 and see what happens. See, now it is rotating. If I make it 1, it is rotating slowly. 2, faster, 100, very fast. 1000, a lot faster. Okay, so yeah, we can use this. We can dynamically rotate the blades. Okay, so similarly we can add another transform modifier bone for the rear blades as well. I'll use the same parameter, and here I'll add set rear wing base and compile. Oh, and it's actually not yaw that we need to modify. That should be pitch. Yeah, pitch. Okay, now this is correct, so let's test this. Alright, we didn't still set the animation blueprint. Here BPA helicopter. Right, and we these wings blades shouldn't rotate by default, so I set the RPM to 0, the default value, and compile, and it should only start rotating where once it reach the proper required RPM. Right, now since this is the blueprint is helicopter, and it's most likely that I will only use this helicopter blueprint only with the helicopter animation blueprint only with the helicopter blueprint. So therefore in this instant I'll get the mesh and get anim instance and cast to BPA helicopter. Usually I don't use casting if this as it increase the coupling between the component, but in this case I think it's okay. Right, now here I'll promote this to a variable BPA helicopter. Okay, so I need some input to increase the RPM of the helicopter. So let's go to project settings. Under this we should have axis. Yeah, these are the usual axis settings that we have. These are discounts by default in the project because I have used the third-person template. So here I'll add another input, move up, and as the key I'll use left shift, scale 1, and to move down I'll use left control, so scale -1. Okay, then here I'll move up axis cement, and this will be either 0, yes, this will be value in between 0, in between -1 and 1. So I'll add another variable, I'll call it RPM. So I'm gonna use this move up axis to control the RPM. So set RPM like this. If we have a negative value here, I'm going to reduce the RPM. If we have a positive value here, I'm going to increase the RPM. So like this, get the RPM and add to that this axis value. I'm gonna multiply this with some multiplier because I don't want to increase the RPM from 0 to 10 instantly. So 0.01. Okay, and also RPM should not be negative, so clamp this value in between. Also I don't think it should not go higher than 10. Let's make it like this, right? And then I'm gonna set the RPM value of the BPA helicopter. But to do that, get this one first. I have to make sure if I have a valid reference, otherwise I might get access none trying to type of error, like basically I'm trying to access a null reference error. Here set RPM with this value. Okay, now if I press shift, you can see blades starts rotating and eventually it will reach the speed of 10. And if I release it, it will stay in the speed, and if I press Ctrl, it will slow down and stop like this. Okay, now the next thing is I need to add a machine sound effect also, and that also should match with this RPM. So actually I have already imported this sound effect, and let me drag and drop it here. Sound. Okay, and here I'll set, I should be able to set the pitch. Set pitch multiplier, yeah. So you know this pitch is changing from 0 to 10, so I don't think I should add 10 as a multiplier, so I'll divide this by 10 and use it as the pitch multiplier. Now let's see. Why? No, that's not correct. Why is that? Also this has to loop. Oh, I have to set that here. Okay. Well, I actually did a little bit of a Google search and I found out this. We have to create a sound cue, helicopter sound cue, and here let's need to make this loop in and use this continuous modulator. So here we can do what we need, and I'll name this parameter pitch, modulation parameter as pitch, and if I play this you can see the sound, and if I reduce the value you can see the sound is reducing. Okay, by default I'll make it 1. Now let me stop this, and then here instead of helicopter sound I'll use helicopter sound cue, and here instead of this one I can use set parameter, set float parameter. Name is pitch, value is this value we calculate here. Okay, now let's play. By default we have this sound, we need to stop that as well, but you will notice as this rotate, we get the gradually increasing sound, and if I press Ctrl you can see it stops. So we need to completely stop the sound effect. So for that, here let's add a branch. Using the RPM. If RPM is larger than 0, I'll make this one, I'll disable auto activate. So this will not be playing by default. See, now it's not there. Then here I'll get the sound and activate it. Again, if this is false, I'm gonna get the same sound and deactivate. Also, this should happen only once. Even though if I do it multiple times, I'm not sure if that causes a problem, but anyway, let's add a do once node here for both cases. Do once, and then only if this is activated we should be able to deactivate, and only if this is deactivated we should be able to activate. Now I will not have sound unless the blades are rotating. Now if I press shift, helicopter starts the sound, right? And if I press control and stop the engine, it completely stops. Okay, so I'm gonna stop this episode right here, and in the next episode I'm gonna look into how to implement this helicopter moving up and then moving around. Oh no, let's do that part also here. Why not? We have only taken about half an hour. Okay, so how to move up? Right, now here we have the move up axis, and this part is only relevant for the sounds. So I'll move this, setting the pitch part also into that area and collapse it. We can use the same RPM variable here. I'll name it engine sound. Okay. Now the way I'm planning is, once the helicopter reach the 10 RPM, if I further keep the move up axis value 1, that means if I further keep the shift pressed, the helicopter should start moving up. Okay, so to do that, we can get the value here, RPM plus the axis value. So if this is larger than, well, max value for the RPM is 10. If this is larger than 10, then I'll add, using this floating point movement, I'll add the movement input. I'll do that here for now. Oh wait, no. Let's keep this part only for the RPM calculation. And let's control the movement inputs in the tick. Yeah, that would be better. Right, for that I'll add a boolean variable, airborne. No, not airborne, in air. I'll make it a boolean variable. Okay, and by default it will be false, and when the RPM reaches 10, I'll make in air true. So true using this. If this value is larger than 10, in air is true. Oh wait, let's not take 10, let's take 9. If this value, or whatever the value in RPM, if it is larger than 10, sorry, larger than 9, I'll consider it as airborne. Oh sorry, in air, not airborne. Get in air, add a branch, if this is true, and also get move up vector value and add using the floating movement. I don't think I have to have a reference. Add movement input, scale value this, and the direction is along Z axis. Right, let's test. See, it is moving up now. Okay, and we can't actually move down. The reason we can't move down is this. So if I press Ctrl, that means I will get a negative axis value, and when I get that, this RPM reduces from 10 to something lower than 9. Once it reaches something lower than 9, this in air variable becomes false, so this part will not work anymore. So once the helicopter is in air, this logic has to change. But how do we change it? Okay, let's have another branch here. If we are in air, if we are not in air, we can execute this path. Once we are in the air, we shouldn't execute this path. Then what should happen is, let me collapse this part. Wait, we can use RPM like this. No need to drag a line from here. Let me collapse this. Not in air. Okay, now we should be able to move up and down freely once we are airborne. So we can move down as well. And yeah, it crashes on the ground. We will fix that later. Okay, I think we have to enable. Don't we have collision? Oh, right, this should be the problem. Let's enable pawn collision. Now let's check if it goes through the ground. It's not moving up now. Why is that? Are we already in collision with anything? Let's check the physics asset of this. Oh, not this one. Physics asset of the helicopter. Alright. Maybe this is the problem. Let me remove that. And check. No, still not moving. Maybe because of the colliders. Let me show the colliders. Or go here. Yeah, and then okay, some of the tires are in the ground. Let me move them up. Still not. Let me adjust. Move this up a bit. Process. Right. Now it's moving up and down. Okay. Actually, ground is not the problem, I think. Why it doesn't go further down than this? Okay, so anyway, we can move up now. Let me show collisions. I have to save this. Well, it seems like the root has somewhat of a offset in this chopper helicopter model. So as a workaround for that, actually we can I will fix it in the model itself, but as a temporary workaround, let me add here, let me add a cube, and I'll use that as the root object. So the cube is here. If I look at it in the side, yeah, lower part of the tire matches with the cube. And also this is block called dynamic. I think I should set it for I'll call it root, and I'll make it invisible or hidden in game. Right now, let's place it like this, and now let's test. Okay, it can go move up and move down like this. Right, if once I'm on the ground and if I keep control pressed, the engine should stop. Okay, so to detect if we are not on ground anymore, what we can do is we can use the collision of this object. I think get the root, and we can't actually set it to overlap with other objects, so let me add another collider. This, and it is already overlap all dynamics. On component begin overlap, if this starts overlapping with some other object, I'll set it set the in air to false, so we should be able to stop the engine as well. And also I think this move up and move down speed is a bit fast, so we can add some smoothing effect with using an additional variable. But before that, let's see if this in-air part works. This won't work because here, even if I set in-air to false, it will make instantly this part true as this conditions becomes true, because by that time we might have the RPM larger than 9. So what we can do is, if we can check if this value is larger than 10. Let's try it now. Okay, we can move up, and move down part is still not working. Okay. Why? Right, make sure this ground also generate overlap events, otherwise that part may not work. But also we can implement a line trace based approach as well. Let's look into that later. Now this is what happens. I can lift off the ground, and I can move down as well. And if I keep control pressed, the chopper will stop the engine like this. Alright, now let's fine tune the move up and move down speed, because it's actually doesn't have any swaying of the chopper. Like it's go up in a straight line and go down. So instead of that, I think, let me promote this to a variable. Move up. And I'll use that. So without using it like this, I'm gonna get the move up value and lump it with this value, the 0.1. Now let's see. Still too fast, I think. Okay. Alright, that's better. Right, also when the chopper take off, helicopter take off, it stays, it goes in a straight line. It doesn't have any of the movement, so that doesn't look realistic. So it would be better if this have some kind of a hanging like movement, like move a bit forward and backward, left and right, like that kind of a movement would make it look more realistic. So for that I'll add, so let's do something like this. Get the mesh, move component 2, and I'll do it once. Let's do once, and once it is completed, let's reset it. Relative rotation, can we do a random point in bounding box? Okay, so here location is this. Let me copy that Oh, we can't paste. 00540. That's the origin. Box extent, I'll make it 10 10 10, and relative rotation, can you get a random rotate? Oh, no, let's let me split this, create random floating range. Let's give something in between -2 and 2 for all of these, and time also random floating range, could be anything in between 2 and 5. Right, shall we test how it looks? Yeah, I think it looks good. Also, let's detach the camera from the mesh and attach it to the root. So then the movement of the helicopter mesh will be independent from the camera, so we will see the movement more. Also, let's enable ease in and ease out. Shortest rotation, and for X and Y, let's have a bit larger value. Yeah, it's better. We see the moment, it doesn't stay exactly in the same spot, it has some movement. Great. Now we have to do is move forward, backward, and left, right. So how do we do that? We can use move forward axis, and just like here we can add a moment input. For this also we might need a variable forward. Get the variable and loop it with the value we get here, alpha 0.1, and we can add movement input along the forward vector, actor forward vector. Value is this, yeah, that value. And this also should work only if we are airborne. So only if we are in the air, not airborne. I always change that. In air. at the moment if I press WOS, nothing happens because we are still on the ground. And once I add, now we can move forward and backward. But when we do this, there should be some movement in the helicopter body as well. When we move forward, it should turn its nose down a bit forward. Okay, so to do that, let's add another scene component here. I'll call it road is here. Let's call it helicopter road, and I'll put the helicopter mesh under that. So when I'm rotated like this, the helicopter body will also rotate. Wait, not that. This one. I'm gonna rotate this one. Okay. So similarly, I'll add move right axis as well. This should also work in the same way. And here, instead of forward, I'll use another variable, right. And world direction is actor right vector. Okay, and we should change the rotation of this helicopter route based on the forward and right values. So if we are moving forward, the pitch should -2 should be a minus value. If we are moving to the right, x roll should be a positive value. Okay, that's the way it needs to change. So get the helicopter route, set relative rotation, we can directly set it because we already have a smoothing function here for forward values and right values. So split this. If we are moving forward, pitch should be a negative value. So multiply this by, say, -2. Maybe we will have to increase this value. Let's first try with -4 and roll. Right here we don't have to change the direction, so multiply with a +4. We don't have to change at all. Okay, now if I want to move forward, press W and it moves like this, and if I want to move backward, it comes back like this. Similarly, left to the left and to the right. Okay, and Now the only thing we need is a way to turn. So for that I'm gonna use another input. Or we have turn. No, that's mouse input. We can use Q and E. So should that be axis? Yeah. Turn. Helicopter. Q and E. Q should be -1, E should be +1. Okay, so now where should we set it? Here. Turn helicopter. This also should happen only if we are airborne. Let me duplicate that part. Wait. Turn. Not replace this with turn and turn. Okay. Now we have to add and here let's set actor rotation. Here we only change in the yaw component, not other components. So get actor rotation, split this, add to this whatever the turn value we get here and use it as the new view. Alright, let's try. Okay. Right. Okay, it is working, but I think the speed should be lower. This must be lower. We can multiply this with the value like 0.2. And similarly move up the speed as well. I feel that's also a bit faster. turning speed is too slow. We have to increase the turning speed. 0.6. Oh, sorry. Actually, that was not the problem. The problem is this. Problem is I haven't added this part. Okay, now let's try. Right, rotation speed is also fine, moment also fine, and everything is working great. So okay, I think I can stop this episode right here. Okay, when we are on ground, we have to make sure these are also placed on the ground. So that means we have to cancel if we have any of the locations offsets for this, any of these local location offsets for mesh and for helicopter route. Right, to fix that offset issue, what we can do is, when we set this in out of walls, we can get the helicopter route and the mesh both. Let me move it over here, turn it on landed, no component 2. Helicopter route, everything should become 0, 0. Quickly, and the mesh as well. Component 2. So here there is some offset for the mesh, 540. That should be there, and the rotation should be cancelled. 0.4. Okay. I think that's all we have to do. I added some objects to see the helicopter moving. Now let's see. Try to land it on this platform. I don't remember if I have collisions on this. Oh wait. One more thing. to enable overlap events to allow chopper to stop on those. Okay. I enabled the wrong tick. This is something else. Generate overlap events during level stream. That's not what I should have enabled. I should have enabled this normal generate overlap events. Okay, let me try again. Down. Okay, alright. So here I am going to stop this episode. If I want, I can take off from here. Okay, so thanks for watching. As always, project files will be available for the download in Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.